For the build milestone of our project, we have set up a build server and used the Jenkins CI tool to configure the build environment. We have used post commit hooks to trigger builds upon git commits. Let's try to make a commit and see if a build gets triggered. We go to the Jenkins dashboard, onto the master job, and there we see a build getting triggered. These are the configurations that we have set up on Jenkins for the environment of this particular job. The repository URL here points to the local Git repository against which we want to track changes. As a post build step, we have set up a simple task to send email notifications in case there are failed builds. We have used the Jacoco Jenkins plugin to measure and report the test coverage metrics for our project. For static analysis of the project, we have used Findbugs to report any static warnings that are present in our project source. For automated test cases generation, we have used a test suite generation framework called EvoSuite. Let's take a look at a few test cases generated by EvoSuite. So these are a few test cases that EvoSuite generated for us for one of the classes in our project to boost the test coverage percentage. For other requirements, we have used a pre-commit hook to detect for the presence of any config tokens or security keys present in the current commits. We also added a few conditions in our post commit script to check if the current commits do not break the minimum required testing coverage threshold. For the first two tasks, we have adopted the blue-green deployment strategy. The first task is taken care of by an init script, which basically provisions two servers on DigitalOcean, which acts as our blue and green slices. Once the two servers are provisioned, we install some basic packages such as Git and Maven, which are required for our application using an Ansible playbook. Another important task of this init script is to create basic installation scripts for both the nodes. The job of this basic installation script is to set up the folder structure and set up the bare git init repositories on the remote hosts. This is one of the installation script for one of the blue nodes. Once this is done, we just go SSH into the production servers and install and run the installation scripts. After the installation scripts are run, we basically go into our project source and set these production hosts as the remote repositories for master. For the monitoring task, we have used a tool called Nagios. Now here we have a remote production host already running, and we have configured a Nagios server on localhost to monitor this particular production host. This is the particular production host which we are monitoring, and as we can see, this is the IP address of the remote production host. We can have a status detail for this host where Nagios keeps on monitoring all the basic services. For performing the Canary release, there are two main components. One is the global Redis store and the second one is a proxy server. The proxy server is a request router, whereas the global Redis store contains the information that affects the routing mechanism. We also expose API endpoints like these, which update the information in the Redis store, which indirectly affects the behavior of the proxy server.
We have written two monkey scripts. One is the restart monkey and another one is the trainer monkey. Restart monkey simply restarts the Tomcat server on which our application is running, and after restarting the server, it just makes a REST call to check if the application is live or not. Whereas Trainer Monkey, it checks the response time for a request in presence of a significant load on the host machine, and the results of these monkeys are sent via email notifications. As per our milestone 3 strategy, we have two production slices running on different host machines. So what our Chaos Monkey script does is it randomly selects one of the two host machines to run the monkey script on, and after choosing the host, it will randomly select one of these monkeys, either restart monkey or trainer monkey, and then it SSHs on the selected host machine and runs the selected monkey on it. So basically we are running a cron job, and it periodically starts the Chaos Monkey script and runs any random monkey on any random host machines from our two production machines. So I'll just show you. I'll just run the Chaos Monkey script. So as you can see, it has randomly selected the host machine 208.68.38.70, and then it has randomly selected to run restart monkey on that host machine. So it shows that it has killed the Tomcat server and it is restarting it. So it says that status of the Tomcat server is 200 and it is alive, and let's see. So we have received the notification of the restart monkey that Tomcat server has passed. Now let us try running Chaos Monkey again. So this time, as you can see, Chaos Monkey has randomly selected the host machine 198.211.100.80 and has randomly selected to run Stress Monkey on it. Now we have used StressNG to perform stress test on the host machine. As you can see, this stress test has randomly selected to start one CPU worker thread, 3 IO sync threads, and 2 virtual machines, each with 1 GB of memory, and this stress test will run for 60 seconds. As you can see, Stress Monkey has finished executing on this host machine. Now, as a part of notification, this Stress Monkey might have sent an email notification with the results. So as you can see, we have already received an email from the Stress Monkey, and it says that the curl application to Greenhouse after this stress test took 50 milliseconds, and it says it's a warning.